Welcome back to our course on product engineering and design thinking. Today we will be in the module 4, the last lecture of module 4, that is the morphological design concept. First I will go to the concept covered slide. We will discuss what is morphological chart. Briefly, that is actually to generate design alternatives. We will discuss some salient points on that, about that, and the method associated with it. Then the generating of alternative concepts and developing generated concepts, morphological matrix, and then we will discuss with a case example or an example with a forklift truck, which perhaps you have seen, or you might have seen the video if you have not visited any factory as such. So, which is used for material handling, that the piece of equipment is a very effective mobility device for material handling. Then we will talk about the morphological synthesis, and there actually we would say that the next logical phase would be the concept evaluation. After generation, the next step is evaluation, which actually is the input for the embodiment design. So, next module where we would be discussing embodiment design, as an input to embodiment design, we will discuss the concept evaluation method. One of the concept evaluation methods, other methods are there. We will be discussing just one method there, which is a very useful method. So, before delving into the detail, we will discuss Pugh method, which is the concept evaluation. That is the initiation I am telling you here. And so, we will go to these slides now, and it is, first let us understand the utility of this chart. It is a structured approach, a structured framework. It was developed by Fritz Zwicky, and it provides a structured framework for systematic process in problem solving in the context of concept generation that would aid in channeling and guiding ideas which are new, additional, and often unanticipated as a design solution to a problem. It may be noted that the problem formulation and the choice of basic elements actually determines the outcome of a design. That is the most important. The first is it is channelizing the idea, guiding the idea, and the second point is that in the beginning, if we are doing this, then actually it determines the outcome of idea. How are we selecting the elements in the design process? That we will see as we move forward. It is possible that a problem is solved by developing alternative solutions involving a form, configuration of a product with different combinations of such elements. Say a transmission can be done by say gear systems, it can be done by chain sprockets, it can be done by belt pulley, and several other methods. Which one for a particular application or particular concept we will take for a function, that would determine on various other considerations. So, we will go to that. Usually the designer would use judgment there, that is the most important thing, because designer's judgment would be there, but this will give a great help, because now designer normally when one is getting a chart or a structured framework, one is forced to consider the alternatives extensively. I am not using the term exhaustively, but actually so, but it is for a complete range of alternatives are to be explored. This enables the early conception of the product architecture, which actually is the starting point practically for the embodiment design, which very soon we will be discussing in our subsequent sessions. Through this generation of such alternatives, concept alternatives, design concept alternatives, and evaluation of different combinations of sub solutions. So, each sub function will be addressed through certain means, like say, as I said, the rotational movement, say out of these three, suppose it is addressed through the gearbox system, then that becomes the means for that function of rotational motion, and that will be combined in the system. Say in a car, the transmission involves gear, okay? But in some other application in the car, that the transmission, rotational transmission, is done through belt pulley. So, depending on the particular use, where what kind of transmission would be used. So, there are alternative transmission, chain and sprocket for cycle is there. It can be done through gear also, it can be done through belt pulley also, but then which is most suitable for a given situation or application, that judiciously the designer has to determine that. If the structure is not there, there is a possibility that some of the elements would be missed out. So, the salient points we will discuss, that it is a structured approach. The morphological charts provide a structured approach, as I already mentioned, of widening the search space, because we are considering the complete range of the functions or the means for the functions. Say functions may be say 10, 12 functions that we are studying, sub functions we are studying. When I am saying functions here, we are breaking the functions into sub functions, and each sub functions will be dealt with or addressed through certain means, and that will give the sub solutions in each cell, and then some combination of the cells will give the full solution. Now, possibly the cells etc., because you are not seeing the diagram, it may be a little difficult for you to visualize, but hold on for a minute. I will very soon go to those charts when it will be clearer. But before I go to the chart, let us see what it works and how it works. It is a systematic analysis process for the form or configuration. With that a product should be built up. A morphological chart helps in visualization, because the chart helps to see which function, which means, or whether the means are complete, everything, and that visualization helps to explore and capture the alternatives or the means and combinations of achieving those functionalities. It might sound here a bit theoretical, but you have to hold on for a moment or two. As I said, that when we hear that, and then when we go, then it will be absolutely clear to you. Now, for each sub function, because if I do not introduce these terms, then and what they are, it will be difficult for you to grasp there. For each sub function, there could be a number of possible alternative solutions, and the chart lets these solutions be designated and provides a systematic way for considering alternative combinations. Because this slide is not only for the understanding of the charts, which will be coming up just now, but later on when you would be seeking explanation, this will be of great help. This write up will be of great help. This capacitates early consideration of product architecture. That is very important. The product architecture is early on is being planned or being considered, and that architecture ultimately would lead us to the embodiment design. Concepts or options resulting from different combination of sub solutions that would perhaps have not been brought into the visualization zone had the chart not been there. So, that is the important point. It can be used suitably to create, because it is actually the function driven thing. So, it is user centric. So, for a user centered or user centric design, if we intend to see that okay, what is comfortable or convenient for the user, and those are the functions, accordingly if we move, then possibly we would be able to create a design that is that caters to those functions, and thereby it becomes the user centered or very user friendly. So, that is possible through proper attention to this. So, now I will just go into the method, then I will go to the charts. Method is rather simple. Method says that listing of the features or functions that are essential to the product, as I was just telling you now. So, basically what is that? It is to be listed, the functions are to be listed. For example, the function of a mobile phone would be display, storage, power supply, signal reception, sound output, etc. Similarly, the listing of means, how it can be done, like say I talked about transmission. So, if I talk about creating pressure, then I may talk of mechanical pressure, mechanically generated pressure, it can be hydraulic pressure, it can be pneumatic pressure, so and so forth. So, alternatives are there, those are means. So, charting down the means will have to be there, and there say when we are doing the means, we need to have a generally maintained, like say when if you say that we would be using battery for an electronic gadget, there could be several different types of batteries. So, when you are saying battery, there can be different batteries that we can use as for this purpose as means. Now, the means as well as exploring for good combination. So, now to frame up every possible sub solution, we will very soon see what the sub solution is, that will lead to identify possible combinations of sub solutions. If done judiciously, the total number of combinations may be reasonably short, and from this the best option may be selected. So, this you can say a theoretical preamble. Now, with this theoretical preamble, what you have understood, that there are certain functions of a product, because this description was important, because without the description at hand now and also in future when you revise this, it would be difficult. So, what have we learned? That basically there would be functions on the rows, there would be means on the columns. So, it will form a matrix, and each cell will give a sub solution. Now, we will combine those sub solutions to get the best design. Now, let us see how it goes. Say for example, if we are talking about paper fasteners. So, what are the different types of fasteners possible? Flexible clamp, paper clip with gem clip, butterfly clamp, staple, that is using stapler. If we are thinking of adhesion, adhesives, glue, sellotape, double sided adhesive tape. Concept generating actually basically is finding or crafting matches between function and means. So, this C for this sub function, say for example, SF1, if we express it as SF1 sub function, the concepts may be C11 and C12. That means, for sub function 1, the first and second means are workable or possible or available or can be created. Similarly, for sub function 2, the 2 1, 2 2, 2 3, that means second, the first, second and third column, that means 3 means are possible or can be utilized. It will be clearer from this short, brief and simple example. Subfunctions, say as I said already, transmit, brake, steer. Suppose these are the subfunctions. These are to a motorcycle, these are the 3 subfunctions. Now, what are the alternative concepts for transmission? The chain, belt, gearbox, as I said just a little while ago. Brake, it may be disc brake, it may be drum brake. For steering, it may be handlebar, it may be control stick, it may be fly-by-wire. So, these are the alternatives possible. All right, we will come back to that. So, now what kind of combination basically would help, that is the purpose. Now, I am presenting a simple example from available literature, because this shows a very simple form of how it is done. Now, if we put those C11, C12, C13 in that matrix, we see the subfunctions on the rows SF1, SF2 and so on to SFM, and alternative concepts or means as we call 1, 2, 3, 4 up till n. So, it is a m by n matrix that we can see. Now, say alternative 1, now there can be multiple alternatives. So, now here the designer would choose, okay, what combination would be useful or economical or attractive or user friendly or whatever the characteristics are according to product design specification, as we had that earlier. So, these combinations, say for from the line which is drawn, you can see the first concept alternative is, it is combination of C11, C22 and then it goes to C31 and then it goes to there are, I mean I am not placing all these things in the rows or columns, just to show you. We will actually deal with an example very soon, and it goes to CM2. So, that is one alternative. So, here you can say alternative 1 is bracket is C11, C22, C31 dot 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 CM2. Similarly, the other alternative is 2, which you can see from the matrix, it is C12, C23, C33 and CM3. This is the approach. Now, we will take up a case of a forklift truck that we just said that, which is used in factory, which is a product, is a material handling equipment product, and it is used for lifting and shifting of material, picking up, storing, etc. For all these purposes it is used. So, this is a forklift truck. If we just see what are the different parameters, I mean this is an example parameters, by no means it is exhaustive, but these are the parameters that we have, say lift, steering, power, propulsion, operator position, rear support, stopping, transmission. Suppose these are 8 such parameters we have chosen for a forklift. We will see how this concept design method is built and created. So, here as we said, the parameters 8 parameters we said, look at the chart, the 8 parameters are placed on the left hand side column in rows. So, against say rear support, how the rear can be supported, tires, it can be caster wheel, air cushion, slide, okay. It here maybe all are not equally suitable or even quite feasible, but then this gives an extensive view before discarding. So, what not to be taken also is to be judiciously considered from the alternatives, but initially they may be there in the chart, otherwise there is a possibility a good option is left out. Now, like that you can see the power. It alternative is petrol, diesel, electric battery, CNG gas, even steam. Now, obviously people would say, okay, forklift with steam is very difficult, because steam generation with coal burning and all this is just out of question. So, then why is steam there? Because it is one of the means of generating power. Similarly, stopping. Stopping can be brakes, disc, drum brakes, ratchet, reverse thrust, and so on and so forth. Lifting can be hydraulic, chain hoist, screw, rope hoist, and so on and so forth. Operator position can be also be changed. One can be seated at the front, one can be seated at the back or rear, even one can stand and make a move, or some, and now there are options to do it remote control, that also is possible. So, this is how the matrix is formed, with an example case as a forklift here. So, now here if we see multiple options are possible. I have shown it with only two options with two different color lines. One is with black dashed lines and other is the blue dotted lines. So, here one is considering the two alternatives where it is touching. The circle marks may indicate that okay, there is some preference on that, but be that as it may, there can be other symbols to highlight that, but then idea is to first find out which is connecting to what. That is the most important thing. So, here as we see that one alternative is that rear support is tire, propulsion is electric motor, power is electric battery, transmission is the gears and shafts, steering is turning wheel, that is wheel, then stopping is drum brake, lifting is chain hoist, and the operator sits at the rear. These are the parameters or sub-functions as we call it. So, these are the means and these are the sub-functions or parameters. So, from this what we realize is that this can create multiple alternatives in the design. And when you are saying multiple alternatives, it is shown with two, but for a large system it may be actually more. And now similarly, this can be done for a particular sub part of a system, this morphological analysis, and then multiple sub parts will then be added together to give the main system. Say for example, if we break the car down into say engine, the propulsion, the powertrain, or if we exclude the engine and make a drivetrain, or say we call the chassis system. So, each can be divided into sub functions, and then those sub functions can further be grouped together or added together or assimilated together to give the complete configuration. Here it is interesting to note that we are discussing here in the first top item in the blue zone, because rest all are the product development process, starting from the data collection, analysis, etc. So, we are not going there. What we are saying, because we have already discussed it, we are showing the different tasks. Logically, it leads us back to the implementation, but we have not discussed that yet. We have discussed morphological synthesis or the matrix as we are discussing here for concept generation. But generation is one part, and then from the so many generated output, one is the judicious decision and other is some systematic method again, which out of say few judiciously selected, when we categorically say judiciously selected are 3, 4, 5 or whatever, and when we want to select further into that to come to a conclusion very analytically, logically and quantitatively, then for the very accurate method we need to have a systematic concept evaluation technique that we will discuss in our subsequent lectures. Say for example, we will be discussing Pugh method, which is actually the entry point of embodiment design, that the correct solution is being selected, which will be taken forward in embodiment design, which we will take up. Here one thing at the end, this morphological design, it helps finally through these steps, if it is done correctly, to build the right architecture into a good prototype or MVP for pilot. So, prototype or MVP, prototype we understand, a MVP is minimum viable product, that is where some of the features are to be tested prior to building the complete product. So, minimum viable product where not all the features are included as it would be for a product, but the core features, the basic features, which we had already discussed in one of our sessions in Kano feature selection, and for that a very good method would be this morphological analysis. Using that morphological analysis, such prototypes or MVP would be prepared or built to give a very good and effective result. So, from here we will take up in the next session. Here I would like to conclude this session that the morphological chart commonly used in generating alternative concepts is discussed with elucidation on the matrix development and creating the combinations of alternative design choices and illustrating the process with an example, which we did with a forklift truck here. I am sure you may try simpler or a complex such thing and do a morphological analysis by yourself, taking up a vacuum cleaner or washing machine or any other product that you like to have, or a mobile phone, and that is your choice. But please do it, it would help. Otherwise, this lecture content is there for you to understand things. And so, for future discussions, you can look at the prescribed reference, the lecture notes, and that will help you in revising the knowledge that you are learning here. Thank you very much. Thank you for attending this program.